Okay, good morning everyone. We are from Group 7 from Manufacturing Process for IE class. We are going to explain about grinding process. This group consists of me, myself, Eugenia Jen, with Krishna Rahul Dharma and Sandi Bufinda. First of all, I would like to explain about the definition of the grinding process. Next slide, please. So grinding is a material removal and surface generation process used to shape and finish components made of metals and other materials. So the key points of this manufacturing process is the first one is abrasive machining, which uses hard non-metallic particles to cut the workpiece. The second one is this is one of finishing processes, which in this process, rough surface of metallic or non-metallic element can rub by rotating wheel, and it removes some parts of workpiece and give them desired finish. And the last is grinding wheel as a cut. Next slide, please. Next slide, please. Okay, so here's the types of grinding process. The first one is surface grinding. In this process, the workpiece is fixed on a table and the wheel is rotated at high speed to perform grinding. The second one is cylindrical grinding. In this process, this is using either a cylindrical grinding machine or a universal grinding machine. Both the cylindrical workpiece and the wheel are rotated and the outer periphery of the workpiece is machined. Next slide, please. The third type of the grinding process is internal grinding. In this process, the workpiece is fixed and the inner surface of the workpiece is machined with rotating axle wheel. And the last is centerless grinding. In this process, the workpiece is supported between a fixed blade and a rotating adjusting wheel and a grinding wheel. Next, the grinding process will be explained by Sandy.
Thank you, Kak Jen. Then, grinding process, I will explain it step by step. First, ensure the proper wheel for the stock is being used. Second, clean the bed before placing the workpiece onto it. Third, place magnetic parallels around the workpiece. Workpiece does not shift during grinding. Fourth, turn the magnetic chuck on to secure the piece onto the bed. 5. Adjust the bed and saddle position to center the stock below the wheel. 6. Lower the wheel an inch above the workpiece. 7. Take a piece of paper and place it between the wheel and stock. Move the paper back and forth while simultaneously lowering the wheel until the paper is no longer able to move the 0 z-axis. Zero the z-axis of the workpiece by setting the dial on downfeed hand wheel to 0 inch. 9. Lock the table longitudinal stock setting block so that there is about an inch of over travel at each end of the treble stroke. 10. Adjust the table position so the wheels sit about an inch to the right of the workpiece. 11. Lower the wheel to the desired depth of grinding. There should be maximum downfeed of 0.001 inch per pass. 12. Ensure the wheel is not in contact with the workpiece before turning the main power on. Press the green button to turn spindle on and turn the coolant switch on. 13. Grind the stock by making passes left to the right along the x-axis. 14. Once the first strip of the workpiece has been sufficiently ground, turn the y-axis hand wheel half a turn clockwise. 15. Grind another strip of the workpiece from left to the right along the x-axis. 16. Repeat until the workpiece is fully ground, then repeat all the previous step for the other side. That's all for next will be delivered by Kak Krishna.
Okay, thank you, Sandy. So now I will be talking about the grinding applications, and this is the general applications of grinding. And there's slithing and parting, and then surface finishing, deburring and descaling, abrasive milling, finishing cylindrical and flat surface, grinding of various tools and cutters. Next, please. So continuing with the grinding applications, but this one is more specific towards each type of grinding. So as mentioned earlier by Jen, a cylindrical grinding process is used for the outer surface of a cylindrical object, and then a centerless grinding process is used for preparing the transmission bushing, shouldered pins, and ceramic shafts for circulator pumps. Internal grinding process is used for finishing the tapered, straight, and formed holes precisely. And then there are few grinders used for sharpen the milling cutters, taps, other various machine cutting tools, cutters, and reamers. Next, please. So lastly, we're going to talk about the grinding advantages. And then the first advantage is the investment is less, is because the grinding machine doesn't really require a lot of tools like other machining process such as milling and turning. And then the working principle is also very simple, the working principle of operation, and then it doesn't require additional skills. And then surface finishing will be approximate 10 times better as compared to milling and turning process of machining. This is because usually the grinding machine will use a very good object for the polishing, and then the dimensional accuracy will be quite good. And lastly, the grinding process could be performed on hardened and also unhardened workpieces. So I think that's all for our presentation today. So I hope you guys learned something from it. So thank you guys.